All right. So I think we actually have a little bit of time if we want to take some questions that we've seen in the Q&A for a few minutes. That sound reasonable? Okay, let me grab them. Sean, will you use a microphone? Do you want to stand up here? Okay. All right, so we've got one here.
I'll pass it around.
Okay, fair enough then. So two that I think are related. Are certain EHRs easier to plug into I2B2 Shrine than others? And a related question, how feasible is it for healthcare organizations that use specialty EHRs, for example, KIPU, instead of Epic or Cerner, to incorporate I2B2 into their health systems? And there's some follow-up questions too. But
Great. So orient around two answers. One is there's no preference for a specialty EHR versus a general EHR. And the reason is what Mosa just finished discussing, which is the ontology in I2B2 is completely moldable. So that basically, if your specialty EHR is focusing on a specific kind of patient, then you can customize it so that it has the data elements that are important for your patients. The other thing is, you can, if it names things in a special way, you can map them and have a second I2B2 ontology, which has the kind of general way that people talk. And you can also have the way the specialty hospital talks and use those queries interchangeably, or those ontologies interchangeably. Now, regarding extract, transform, and load, which is fundamentally what you do need to do when you take data out of your electronic medical record and you put it into I2B2. So traditionally, I mean, it's a task which, depending on how well the data is organized inside the EHR, it'll be harder or easier. Now, the ultimately most difficult to organize is often data that is kind of in the form of question answers, and that is patient-reported outcomes and survey data, because it has to be kind of made into an ontology that looks like, you know, a lot of hierarchical items, which it often is. And that's traditionally been difficult and hampered people from taking really specialized kinds of questions and putting them into an I2B2 format. However, Jeff over here has been working very closely with a number of grant-oriented survey types of data collection efforts that we have in eMERGE, for example, that we have in the Gregor project, that we have in Recover, and put a large language model around those to organize the data into ontologies and to write Python programs to transform the data into the I2B2 format. So I think that's the future of, you know, trying to get the extract, transfer, and load process to be easier, is to leverage large language models to do that.
all right, thank you. Another question here. How can we better leverage I2B2 or similar platforms to model not just observed patient-reported outcome scores, but also patterns of missingness, especially when system-level factors like local protocols, wait time, staffing may drive both care engagement and data capture?
So I don't know if we can fix very specific kinds of missing problems, but missing data is a general problem that we have in I2B2 and across healthcare. And the reason is, what we try to address is when people either we expect a series of measurements and then people don't have the measurement at different times for different reasons. Maybe they're too sick or something of that nature. Or that people leave the healthcare system, so they can't get measured because they're out of the healthcare system. So there's kind of two approaches that are generally used. The first one is imputation. So you have a series of lab values. They're all, a sodium of 145 over and over, and then, you have one missing value. And then it's like, can't you just impute that to be 145? And that's what that means. Now, the problem is that that might be actually the one time when it's not 145, right? Maybe the patient didn't get the measurement because they were in the ICU at that time, and so they didn't. So it's a little dangerous to do that. And actually, in general, hospitals are forbidden to do that. So when they present a lab, you can't present a line connecting two lab values, for example. Okay. So, but imputation is a way that sometimes people deal with that kind of thing. The second one is selection. So selecting patients, for example, who, and this is pretty common, people, you start with 800 patients in a study, and then you have to eliminate, 200 of them because a lot of them have missing values. So we're kind of doing the same thing in healthcare with the loyalty cohort. So again, Jeff has been working very hard to make something called the loyalty cohort out of your healthcare data, which does indeed preserve patients who are there for some not proven period of time, but when it would be very reasonable to assume that they've been there for a long period of time because they've gotten all their colonoscopies there, they've gotten all their vaccines there, everything you would expect them to have gotten in the healthcare system, they have gotten, well care visits and so forth. So that's the second way to deal with missingness.
Right. Sort of related question, are patients with complete data sets different from the clinical population as a whole?
So actually, I should have Jeff answer that one.
Got a hand up behind you as well. I think Griffin is also
Griffin too, okay.
also open to answering.
Okay. We published a paper, and that was one of our additions in the revision. So it turns out that yes, there are slight differences between an average patient and a patient with complete data, but none of them were statistically significant. And the population overall looked approximately the same. So it doesn't seem to bias your data to pick only the patients with complete data.
Okay. Griffin might have a comment behind you too.
Griffin.
Pass the mic.
We had a grant looking at claims data where you do have longitudinal information seeing how patients move between healthcare systems to look into that in more detail. So there's a little bit of semantics. So for patients who truly get 100% of their care at one institution, these are usually really healthy patients. They come once a year for an annual checkup or some screening tests, and there's nothing really clinically wrong with them. So usually younger, male, in certain geographic regions. That's a little bit different from seeing patients who receive most of their care at one institution. And a lot of the loyalty cohort algorithms that Jeff were talking about are finding those patients who receive most of their care, but you're not guaranteeing it's 100% of it. And the patients who receive most of their care at one institution, they tend to be sicker. They're getting a lot of visits, a lot of other things that pass the regression equation that is selecting for patients who are at the institution. So there's a little bit of that distinction between 100% loyal and almost loyal, and what kind of patients you get out of that. You have to be cautious of any of these different approaches because of the biases that they introduce into the patients that you're looking at.
All right. I'll ask one more question if I might. This is actually a part of one here. So for somebody who may be inspired to start to work with I2B2, question here about resources. Is there a quick start kit available or consulting, troubleshooting resources within I2B2? So if we've inspired anybody to work with I2B2, what might be available to them if we got to them today and piqued interest?
So the first thing I would suggest is you go to the I2B2 site and you sign up for the mailing list. Getting to Diane Keogh is the person to make sure that you get those resources. We, the install mailing list provides help to install I2B2 at your establishment, whatever that might be. Now, of course, there's a lot of documentation that is associated with the community.i2b2.org website. But at the end of the day, I2B2 is a hands-on process. And so it's really, there is a absolute learning curve about what the data has to look like, what it means to have these ontologies to query the data, and being able to actually, have the software put on a platform of your choice. Now it works on Linux systems like Ubuntu. It works on Windows systems on the server side, and then the client is all web programming, so it works on all the different popular web browsers. What else should we say, Griffin? Jeff? Now I have to say, so the person that knows the most about everything is Mike Mendez sitting over there, but I'll just maybe ask him if he has any thoughts.
I like putting me on the spot.
Yeah, why not? Any thoughts about if somebody wanted to start with I2B2, Mike, your recommendation?
So so one thing is copies Dockers. That's really a good starting point. There's also the virtual machines. So on the website, we have the virtual machines that basically has everything installed: the web client, the I2B2 software, all the data in Postgres. So it's easily, you just click it, start it up. It will tell you exactly what your IP is, and you just go to your web client and go there, and then you can start querying it. There's also the demo site that you can actually just query and understand the web client. So those are, and there's documentation.
And when we say all the data, we mean demo data.
That's right.
Demo data, just to be clear. Because one, I think, misconception that there often is about what I2B2 really kind of has is it has software, but ultimately it has to connect to your data. So it doesn't come with data from hospitals or something like that. It comes with a demo data set, which is totally fake, but that's about it. And so it's like you really have to kind of have the data that you want to host available to you, and then you kind of wrap I2B2 around it.